Hello student, welcome to my official YouTube channel Mathematics All Level by Akib Khan. So today we are discussing the second part of the exponential and logarithmic functions. I've already made the basic, the first part of this particular chapter and in which I have discussed the basic concepts of exponential and logarithmic function. Today we will be discussing about the laws related to these concepts. First of all, why do we need these laws? So let's say log, I'm just taking directly an equation for you. So let's say log 2 base of 8 plus of log 2 base of let's say 2. I'm just writing an equation, don't get confused. So log 2 base of 16. So if you don't know these laws till now, so what do you will infer from here is that the equation written here is incorrect. Okay, this you will infer, but the thing is, due to the laws of logarithm, these this equation which I have written here is correct. Okay, why do we need these laws? In A level examination we need to simplify that complex logarithmic expression, so it will be easier for us to solve in means involving the multiple logs or expressing answers in terms of other variables. So that is why we need these laws. Okay, so the left hand side and right hand side of this particular equations are equal, don't get confused. I was just telling you that if you don't know these laws, so you will infer different meaning from this equation. So let's come to the first fundamental law of logarithm, that is the product law. Okay, what is the product law? For example, I'll take one example for you. Let's say I've written the law here, log a base of mn equals to log a base of m plus log a base of n. So from where did we get this law? Let's say, for example, I've taken log a base m equals to x. For example, we are taking like this. Okay, I've taken log a base m equals to x. Similarly, I've taken log a base n equals to y. So from here, due to I've already told you that how we could calculate here, how we could solve here, that m will be equals to e raised to the power x. Similarly, n will be equals to e raised to the power y. Okay. So if we multiply these terms here, so it will be m cross n. So similarly, in the right hand side, it will be e power x cross of e power y. Okay. So mn will be equals to a raised to the power. We have already learned about the laws of indices in our junior classes. So we know that if the bases are same and these bases are same and the power are different, so the power get added here. So it will be e raised to the power x plus y. So what we can write from here is, in terms of logarithmic format, how we could write here, student, we can write this as log of a base of mn is equals to x plus of y. With the help of the logarithmic expression, I have written this statement, student. Okay, so from here we can say that what we have substituted, the value of x was log of a base m plus of log of n base is a, because y we have taken here as log of n base a and x we have taken log of m base a. Okay, so this is how we can prove this product law, students. This was our first law, in which the log of multiplication becomes an addition of logs. Okay, students, so let's move to the next example. For this, I've taken two of the examples for you. For example, in this first question, students, let's say we will apply the product law here, students. Yes, the product law. So let's say they have given log 6 basis 3 plus of log of 9 basis 3. So what we need to do, we have just learned the product law. So it will be log, base will be 3 and the components inside the angle will be multiplied. So it will be 6 cross of n. It will be equals to log of 54 base 3. Okay, this is what our product law tells us. Similarly, if I say about this, we need to expand this particular logarithmic question. So they have given log of 20 and base is 5. Okay, so can't we write log of 20 base 5? So can't we write 20 as 5 cross of 4? We can write. So if we expand this part with the help of log product law, so what we'll get, log 5 base 5 plus of log of 5 base 4. Okay, just think this product law in reverse, means this we have taken, this was given, and we are calculating the values from here. So in this part, see, log of 5 base 5 plus of log 5 4 base is 5. So we can write this, and we have learned this special properties in our first lecture. So this will be equals to 1 plus of log 4 5. The base is 5. So this is the correct solution of this equation. Students, see, this is the correct equation for this, and this is the correct solution for this equation. Okay, now let's move further. Yeah, second comes a student, the quotient law. What does quotient law state, student? The log of a division becomes a subtractions of a log. Okay, similarly we can prove this law as well. Let's say we have given this particular law here, log of m by n base is a is equals to log of m base a negative of log n base a. What we can do here, same we can do, we can take log of m base a equals to x. Similarly, log of n base a equals to y. Okay, so from here, the help of logarithmic formula, we can directly write that m equals to a raised to the power x and n is equals to a raised to the power y. So if I see here, so they have calculated m by n. So from here also we can directly take m by n. So if we divide these terms, students, these terms, so what we'll get, a by x upon a power y, a raised to the power x upon a raised to the power y. We can write here in the right hand side, student, if I say you, if you apply the law of indices, so what we'll get, we'll get a raised to the power x minus y. Okay, this is the law of indices, law of exponents, we have already studied in our junior classes. So this is how we could write. Now if I convert this thing, this equation in logarithmic form, so what will be the expression for, equation for us? It will be log of base a m by n equals to x negative y. Okay, this could be written from here, and we also have substituted the value of x equals to log m base a and the value of y equals to log n base a. So we can write here directly log of m base a negative of log of n base a. Okay, so we have proved this law, students, that how we are getting this quotient law. Okay, this was our proof, in which this the quotient law state that the log of division becomes the subtractions of log. So we have seen this law here. I have taken certain example on this also. For example, for log of 48 base 2 negative of log of 6 base 2. So according to the quotient law, what will be the solution here? It will be log of 48 divided by 6, okay, and base will be 2 according to the quotient law. 48, it will be 48, yeah. So on further calculating, can we calculate it further? We will get log base will be 2, obviously. It will be 8, okay. We know that in the multiplication table of 6, we get 48 8 times, so it will be 8. And if I do it further, so it will be log of 2. Here we can write 8 as equals to 2 raised to the power 3. Okay, now I'll be solving one extra step for you here. The value will be 3 log of 2 base 2. Don't get confused here. We'll be showing you this particular from where I have got this log here in power law, which is coming in the next slides. It is the power law. This is also correct, don't get confused, but since I have applied the power law, so we'll be getting 3 log 2 base 2, and further and calculating it further we'll get 3, because this is our special property. Log a base a will be 1, so the value will be 3. Okay, don't get confused here. I'll be showing it you in the further slides. Now let's take this example. Log of 50 base 10 negative of log of 2 base 10. Similarly, we'll apply the quotient rule here. So the log 50 negative of log 2 base 10. So we can directly write 50 by 2. Applying the quotient law, it could be written as log of base will be 10, obviously, and the value here will be 25. Okay, so we need to express this as a single logarithm. So we have already expressed this as a single logarithm, student. See, this was the value, this was the solution of first, and this was the solution of second. Now let's move further, which I have told you in the previous slide, that from where we have got that power law. So this was our power law, student. See, log of a, log of m base a. So I'll show you. Let's say, okay, they have given this equals to k log a m base a. Okay, same we need to do. What we can do here, log of m base a equals to x. I've taken this as x, so with the help of logarithmic expression we can write this in the exponential format, that is m equals to a raised to the power x. Okay, now if I say that if I take the power on the both the side, means m raised to the power k equals to a raised to the power x raised to the power k. I've taken the power on both the side. K I have taken as a power here, okay, on both the sides. So it will be m raised to the power k. Now again, law of indices, which we have learned earlier in our previous classes. So according to that law, it will be x a raised to the power x into k. So m power k, m raised to the power k will be equals to a raised to the power xk. Okay. Now if I say that transform this equation in the logarithmic format, so what we can write here is log of a, base will be a from here, and the value which we are calculating was this m raised to the power k, this part. So it will be m raised to the power k, and for this we can write x cross of k. Okay, now again in this part what we have substituted x, students, that was x was log of m base a. So we can write log of m base a, log of m power k base a equals to x. On place of x we can write log of m base a into k. Okay, so this is the proof of this power law, student. One more thing, student, k should be written on the left hand side, because majority of the student, what they will do, they will write k as an angle format, which will be the wrong. Okay, this is the angle. Okay, this is the number which we have discussed. So k is not the number, it is a different part, different term, which is multiplied with the logarithmic log of m base a. Okay, if I write k on the right hand side, so majority of student will get confused here. So this was the uh, proof of the power law, student. The power inside the log can move outside as a multiplier, which we have discussed. Okay, I've taken certain examples on this power law, student. See, first example is log of 9 square base is 3. So what will be the value here? So 2 will be coming outside as a multiplier, and in logarithmic format, what will be remaining? That is log of 9 base 3. On further solving it, student, we'll get 2 log of, now 9 could be written as 3 raised to the power 2 and base was 3. Again, what we need to do, again this 2, this power 2 will be coming outside as a multiplier, so it will be 2 cross of 2 log of, in log what will be remaining, base will be 3 and the number will be 3, and with this we know that this, the value of this will be 1. It will be equals to 2 cross 2 will be equals to 4. Okay, so this is the solution of this question. Now for this, if I say log of base is 5 and number is given as 125. Okay, now root of 125, this could be written as log of 5 is 125. We know that square root in the power in the fraction format, it could be written as power of 1 by 2. We know this already. So what we'll do, we'll apply the power law here, and then similarly 1 by 2 will be coming out as a multiplier. So 1 by 2 log of 125 base is 5. Okay, this power which we have taken outside as a multiplier is 1 by 2, because the expression in the log was square root format. So again, if we solve it further, what we'll get, 1 by 2 log of, now 125, student, it could be again written in the form of 5 raised to the power 3 and the base was 5. Okay, again we are applying the power law here, so 3 will come out as a multiplier, so it will be 3 by 2, because 1 by 2 was already there. So log of 5 base 5, this is our special property, the value will be 1. So the solution for this question will be 3 by 2. Okay, this is the reverse, in which we need to without a coefficient. See, what is without a coefficient? I'll tell, 3 log of x base 4. Okay, what they are asking us, see, I'll tell you. See, this part is a coefficient of log of x base 4. Okay, so they want us to solve in such a way that no coefficient is left. So this is the reverse case of a power law. So we know we can write this as log of base will be 4 x raised to the power 3, applying the power law. Now if I see this term, so it is without a coefficient. Now this 3 comes to the power on x. Okay, this is the reverse format. See, this is the reverse format. K was given here. Now k was outside, it come as a multiplier. Similarly, k could be written on this power as well, on the numbers power as well. For example, log of m base a was there, so this k could be written on the power side of m. So this is what they were asking for. So this is the solution of this. Log of x cube base is 4. Okay, now let's discuss about the uh, common mistake which student does in the examination. The first one is the addition trap. I'll tell you, for example, if I say log of 4 plus of x is given, so what they will do, they will apply the product law here. That will be log of 4 plus of log of x, okay, which is incorrect. Okay, it is applicable, is incorrect. It is applicable only, students, in the format of, when it was given in the format of, in a number format. For example, 4x is given, so we could write this as log of 4 plus of log of x. We can write this in this format. This is the product law, neither this. Okay, because here in the number, the two in the number format, we can see that there are two terms which are getting added. So it can't be written in the format of log of 4 plus of log of x. So this is wrong and this is correct. Whenever this is in the multiplying, in the multiples, see, this is in the multiple format, student. So then we can write in the form of log of 4 plus of log of x. So don't get confused with this. Majority of the student does this thing, okay, which is wrong. Now, second mistake which student does is the power law misapplication. That is, log of x cube base is 2. Now 3 will, obviously 3 will be coming out as a multiplier, so they have written 3 log x base 2. But what if I say that any expression is given as log of x base 2 whole power 3? This is the whole power, student. This is the whole power. This is not the the power is not raised to the number here in the log. It is the whole cube of this particular term. So this can't be written as 3 log of x base 2. Okay, so don't get confused in the power of a number which is in the log and in the power of whole log. Okay, now next mistake which student does is the mismatched bases. Mismatched bases means, see here the bases are log of 8 base 2 and here the base is 3, so it can't get multiplied. Okay, it can't get multiplied. Why is this so? Log of 8 base 2 plus of log of 9 base 2, this could be multiplied, student. So what we need to see, we need to see that first the bases should be equal. Okay, this is the major part. So I've already written that check your bases before applying any law. It should be equal, then only we can apply the this this power law, or sorry, this power law I'm saying, this product law, quotient law, this all could be applied when the bases are equal. Okay, if the bases are not matching, so the this laws will not be applicable here. So this is correct, but this will not be correct. Okay, so be aware of this, student. I'll mark this as a that this is wrong. Okay, let's move further. Now I've taken certain questions for you. Okay, let's do it one by one. For example, in this question, express 2 log x base 3 minus negative log x plus 4 base 3 as a single logarithm. Okay, then let's do it. So first of all, we have to see this log x base 3. 2 is written here as a multiplier. So if we apply the power law here, student, so we can write log of x square Okay, 2 will be in the power of this x, so it will could be written in log of x square base 3. Reverse of power law, negative of log of x plus of 4 base is 3. Okay, now the bases are same. Here we can see that the bases are same. Now if I say, if we apply the quotient law, so it will be log of, in the base will be 3, and the num the part of logarithm will be in the division, so it will be x square by x plus of 4. Okay, so what we have learned here, this is the logarithmic. I'll write it here for you. This was the solution. We have expressed this as a single logarithm, student. Okay, and what we have applied here, reverse of power law. Okay, in the first term. Okay, this I have directly written. Then we have got this as a solution. Now let's move to the next part question. So they have given us that given p equals to log a base 2, express log 8a raised power 5 base 2 in terms of p. So we need to express this in terms of p. Okay, let's do it. Log of 8a raised to power 5. Okay, yes. Log of 8a power 5 basis 2. Okay, first what will apply? The reverse of product law, so it will be log of 8 cross of a power 5. It could be written here. It is obviously it is seen here, and now I'm applying the reverse of product law, so it will be log of 8 base 5 plus of log of e raised to the power 5 basis again 5. Okay, okay, see, I have written by mistake, I have written base as 5 here, so the base will be 2 here, student. It is given in the question, so the base will be 2. In here 2, here will be 2. So law, yeah, now I've applied the reverse of product law. See, now this part, if I say this number log of 8, it could be written in the format of 2 raised to the power 3 base is again 2 plus of log of. This is in the power law format, so this 5 will be coming out as a multiplier, so it will be 5 log of e base 2. Now again, if I calculate it further, in the first term, student, this term p will be outside as a multiplier, reverse of power law, so it will be 3 log 2 base 2 plus of 5. Now this part, if I say this part, they have given this part as p in the question, so we can write 5p. So, and this we have studied in the special properties that this value will be 1. So the value here will be 3 plus of 5p. So what laws we have applied here, student? This is our final solution. Okay. So here we have applied reverse of power law, and in this here we in this expression we have applied reverse of product law. Okay, so I'll write it for you. Okay, this all yeah, this all PowerPoint presentation is available in the description box below. If you want to download it, you can download it as well here. So you just need to click the link which I have provided in the description box. So you'll get this all workings of mine, and even you'll get the presentation as well here. Now next question which I have taken, student, is solve 2 log x base 3 equals to log 4 base 3 plus log x plus 5 base 3. This is good question. So first what we'll do, if I say about left hand side, so in the left hand side, if I see, it will be 2 log of x base 3. Now applying the reverse of power law, it could be written as log of x square base 3. Okay, so our left hand side is done, student. Now let's talk about the right hand side. So in the right hand side, student, log of 4 base 3 plus of log of x plus of 5 base 3. Now first what I've told you that we need to see the bases here. So bases are equal. So we can apply the product law here. Okay, so it will be log of 3, base will be 3, and in here it will be 4 x plus of 5. This will be this will this value in the log will be multiplied. This is the product law. So on calculating it further, we'll get log base 3. Here will be 4x plus of 20. Okay. Now this is the left hand side and this is the right hand side. Now if we equate it further, left hand side and right hand side, so what we'll get, log of x square base 3 equals to log of 4x plus of 20 base is 3. Okay, now what we'll do, we'll take any of the term on the left hand side or right hand side. So we can do it like this here, log of base 3 x square negative of log of base 3 4x plus of 20. I've taken right hand side to the left hand side, so it will be a negative side, so it will be equals to log 0. Okay, on the right hand side it will be no terms will be left. Now if I apply the quotient law here, students, what will get, log of base will be 3 and in the value here it will be x square upon 4x plus of 20 will be equals to 0. Okay, now if I expand it further in the exponential format, from first this is in the logarithmic form. So if I want to calculate in exponential format, I'm opening directly, so it will be 3 raised to the power 0. So it will be on the right hand side, it will be 3 raised to the power 0. So it could be written as x square upon 4x plus of 20 equals to 3 raised to the power 0. I've opened this format in exponential format. So it will be x square upon 4x plus of 20 equals to 3 raised to the power 0 will be 1. Okay, now yeah, yes, on calculating it further, student, what we'll get, x square equals to, I'm doing the cross multiplication thing here, so we'll get 4x plus of 20. Okay, so this could be written as x square negative of 4x negative of 20 equals to 0. From here it is easy to solve. Okay, just show tell me the solution in the comment box below. This is the quadratic equation, so we can directly find this the value of x from this equation by applying the quadratic formula, that is equals to minus plus minus under root d by 4a. So we'll be able to get the value from here. Okay, majority of the student, what they will do, I'll tell you, here they get stuck and they do the mistake. So mistake also I'm highlighting here, student. What they will see that the bases are same here, so they directly they will make this part as a equal. So x square will be equals to 4x plus of 20. Okay, it see, after doing the calculation working here, we are getting the same thing. I'm not denying it, but don't do this part. Okay, this majority of students do. we need to show our working in a presentable manner. So we should apply the first that quotient law. We should show our working step by step. Okay, so majority of the student, they do mistake here. They directly equate the base the value here, because the bases are same, which is correct. I'm not denying it. But whenever the terms are is with the operator sign, for example, if any term would be here, negative of log of 2x base 3, so we need to calculate it further. So I'll request you that you should go step by step instead of directly solving it. So from here we'll get the solution, and this is how we need to proceed this question, students. Now let's move further. Yeah, so I've written the strategy for you. What we need to do first we need to look at the expression. Then if there are any coefficient in the front of log, so obviously we'll need to apply the power law first. Then we need to apply that power law. It could be it will be the reverse of the power law. So we need to move them inside as a power, which I've discussed with you. Any adding logs are there with same basis, then we know that adding logs are there, so we need to apply the product law. Subtracting logs are there, so we need to apply the quotient law. Now if any numerical logarithm is there, for example log of 8 base 2, so we can't leave this solution here itself. We need to solve it further. If it could be written in the form of indices, so we need to calculate it further. Okay, we can't leave this expression here itself. So this is the strategy flow chart, student, which I have given for you. Whatever what strategy you need to follow while looking at the expression. Okay, so now let's move to the next part, that is the what is the memory aid for you for order of operation. That is power law is coefficient will be coming as the power inside. Product law means product, or quotient law means combine logs in the form of multiplication or division. Evaluating whatever we need to calculate it, we need to evaluate it after doing these things. Okay, first we need to operate, we need to move through the step 1 and then step 2, then we can move to step 3. Okay, directly we can't go with the evaluation part. Now afterwards we can substitute if any values are given in the question, which I have shown you in one of my question, that they have given the value as a p. Okay, then we will be able to solve this logarithm questions. Now I've given certain questions for you for you to practice. I'll tell you the strategy behind this question. I'll tell some hint for you also. For example, log of 75 is there, so this reverse of product law could be applied here. After reverse of product law, what we can apply, see, negative sign is there, so we can apply the quotient law. So this is the cheat code for the first question. Second question is expressed as a single logarithm. See here, the coefficient is given, so it will be in the power side. Similarly here, again the coefficient is given as a multiplier, so it will be in the power. So afterwards, here we could apply the product law, here we could apply the quotient law. This is the cheat code for this question. For the third question given, they have given certain value, p equals to log 5 base 3 express log of 45. So here what we need to do, in log of 45 base 3, we can apply the reverse of product law. We need to expand the expression and then we can substitute this particular value. Okay, this is the cheat code for this question. For the fourth question, if I tell you log of square root of 64 x cube basis 4, so log of, I'll write it for you, log of base 4 64x cube could be written in the format of 64x cube raised to the power 1 by 2. Now again this is in the format of power, so this 1 by 2 will be in the will be coming out as the multiplier format. So this is the cheat code for this question. Okay, so just tell me the answers of these questions in the comment box below. Okay. Now, for exam tips and tricks, what I like to I've already told you also, I've already discussed with you that we need to show every steps instead of getting solution early. We can't escape the steps. Okay, whatever we need to see, we need to see the basis first, and whatever the domains, whatever the restrictions they have given, we need to go through it also. We can't means domain we have discussed in the previous video also, that this base can't be equals to 0, can't be equals to 1, it should be positive, the natural number n must be positive. This all awareness should be there, then only we need to proceed it further. Working backwards for you, and some of the good questions, what we can do, we can work backwards to see that if we are getting the question or not. Okay, if the solution we have got, now we can work backwards to know that we are able to get the question or not. From solution we need to get the question. Okay, so this will also be helpful for you. Okay. Okay, this we have already discussed, that in coefficient, power law is needed. In addition, product law is needed. In subtraction, quotient law. Addition inside cannot be simplified. In the logarithmic form, in the value of log, if the addition is there, it can't be simplified. I'll write it again for you. Log of 2, and here it is written x plus 4. It can't be simplified. Don't apply the product law here, students. Okay. So this was our second lecture of this series. Now I'll be coming with the third lecture, in which we'll be discussing the properties of natural logarithm. So hope you like my videos, students. Thank you.